In Revit, all elements belong to a family, and families are organized into categories. For example, when I open the Visibility Graphic Overrides dialog, you can see on the Model Categories tab that there are several model categories, such as doors, floors, roofs, ceilings. And then on the Annotation Categories tab, you can see that there are corresponding annotation categories for tags, as well as other annotation categories, such as text and sections and elevations. And so obviously here's where we can control the visibility, and that is based on the categories. I'll click Cancel, and then I'll zoom in and select a wall. And in the Properties palette, you can see that this is assigned to the Walls category. And if I select a door, you can see it belongs to the Doors category. Now, for system families, such as walls, floors, ceilings, roofs, you cannot adjust the category. So those are family types defined within the Revit project. But for loadable family components, you can control their category. So let's take a look at a few things here. I'm going to click File, New, Family. And when I begin creating a new family, you can select a template file to begin creating that family. And when I scroll through the list, you can see that there are several templates available for the corresponding loadable family categories. Now, there's not one for every single category, and if a specific category is not available, then you can use one of the generic model templates. And then, as we'll see in a minute, you can control the category there. You also want to pay attention to the hosting type. And so as you can see here, there is generic model ceiling-based, face-based, floor-based, line-based, several of them, right? So face-based is very flexible, ceiling-based, floor-based, wall-based, those are all have specific hosts. For this example, I'll select generic model and click open. And so this is an unhosted family. And when you're in the family editor, on the create ribbon in the properties panel, you can click family category and parameters. And this opens the family category and parameters dialog. And here you can control the category. So this is a generic model, but we can switch it to any model category that we wish and then create a family. Once again, you can select the category specific template, but for those that are not available, you can start with a generic model template. I'm going to switch back to the project, and then let's select a door and look at a few other portions of the creating a family. So in this case, we have a door family, and you can see that here's the door and the door swing, and then we also have a door swing on the other side with dashed lines. So I'm going to select that door and click Edit Family to open that door family here in the Family Editor. And you can see that we have the door components here. And then if I switch to the reference level, or sorry, the floor plan view, now we can see those door swings. So there's a lot going on here, and I kind of want to just touch on a few things. We have line work here for the door swing, and you can see these are symbolic lines, and as well as on the other side. And if I select one of the door swings there, you can see a subcategory drop down in the contextual ribbon that can be used to control the subcategory. And so what a subcategory does is it allows you to display certain geometry or line work in a different way inside the project. So once again, we have the door component, the door swing that's solid, and then the door swing that's a dashed line. And if I open the Visibility Graphic Overrides dialog again and expand the Doors category, you can see that there are several subcategories here. And you can control their visibility And then you can also override the projection lines or cut lines. All right, let's switch back here to the door family. And once again, we have the geometry, and so you can create the geometry, and then you can create line work and assign it to a subcategory. And there's a lot of flexibility here in the family editor. In Revit, there are three kinds of families: system families, loadable families, and in-place families. You will use system and loadable families the most, so let's take a look at the differences between those. I'll zoom in and select a door, and when I select a door, you can see that there's an Edit Family tool in the contextual ribbon. So a quick way to identify if a component is a loadable family is to look for this Edit Family tool. What that means is that this component can be opened in the family editor. And so loadable families are defined in the Revit Family Editor and then loaded into a project. If I select a wall, you can see that the Edit Family tool is not available, and that's because a wall is a system family and it is defined within a Revit project or in a project template. So for example, I can click Edit Type, and then this is where this wall family type is defined. And for walls, I can control the structure and define the layers that make up this wall type. I'll click Cancel to close these dialogues, and then I will select a tag. And you can see once again there's an Edit Family button in the contextual ribbon. So loadable families are those components such as doors and windows, and typically a building component that would be purchased and delivered to a site. And loadable families also include tags and other annotation components that can be loaded into a project. System families include elements such as walls, roofs, floors, ceilings, and those are typically elements that will be constructed on the site. And so larger systems, if you will, building systems. And so once again, floors, roofs, walls, and so on and so forth. So for example, I'll select the roof, and once again, that Edit Family tool is not available. All right, I'm going to switch back to the floor plan view and select a door, and then click Edit Family. And now you can see that we're in the Family Editor, and that is a different environment within Revit. So you can see that the ribbon tabs have changed, and we are now working on this specific door family. Within a family, there can be multiple types. And I'll switch back to the project and select the door again. And when you expand the type selector, you can see the available types for that family. So in this case, we have a door, and we have different sizes of doors, and those are the types. And you can see that the door sizes is what makes up the type, and so that's simply by adjusting the parameters to create a new type. So you can have multiple types for each family, and this is the same for both loadable families and system families. One thing to be aware of is that you can adjust family types within the project environment for both system families and loadable families. Just be aware that if you create a new type, for example, if I click Duplicate, and let's just change the height parameter here to 78 inches, and then I'll change the height here to 78 inches. And so now we created a new type, and I'll click OK. Be aware that this type did not also get created in the family. And so that can be one thing that can be a little tricky, is that if you edit it in the project, it's not going to update the family file. But if I close the family file and then I edit the family that I just added the new type to in the project, then that type will be available here. So once again, that can be a little bit tricky. It's not going to update in real time, but if you make the update in the project and then open the family, you will see the new types there. And there are multiple parameters that you can add to a family to make up the different types. You can add formulas to control those parameters, and so there's a lot of flexibility within the family editor. All right, last thing is in-place families. And if you switch to the architecture ribbon and we'll expand the component button, you can see that there's a model in place tool. And so when you create an in-place component, it needs to be unique to the project, meaning that you won't use it in another project, because if you were, you would just create a family. And so that's why in-place components are not used very often, is because they are specific to a project. If I click Model in Place, I can then select a category. For example, I'll select Columns and click OK, and we'll just accept the default name here. And now I am essentially in the Family Editor environment here in the project. And so that's essentially creating an in-place family that is specific to this project. I'm going to cancel now. And so that's typically why those should be used sparingly, because they are not as flexible as a loadable family. So once again, system families defined within a Revit project or project template. Loadable families are .rfa files that are defined in the family editor, and then in-place families which are specific to a project and not as much flexibility.
In this video, we are going to create a wall-based casework family using the appropriate family template. We will establish reference planes as the framework for the family geometry, flex the model by adjusting the parameters to ensure that all constraints are properly set. When creating families, it's important to know how they are categorized and also located within your Revit project. In this very simple model, we have a few different categories that we can take a look at. First off, I'm going to take a look at this door. This door is part of the doors category, and I can look at that in the project browser by expanding families, looking at doors, and then I can see the different door types that are loaded within this project. When I select the door in question here, you can see that this is a door single flush 36 by 84. There's a hierarchy here that's important to understand. When we look at the door single flush, you can see below that there's a series of different types. 36 by 84 is one of the many types within the single flush family. The hierarchy that we're looking at here is category, family, type, and then within our model, we have individual instances of that type. And within the model, we have individual instances of that type. This is helpful to know because if I were to make a change to, say, the instance parameters, then I know that there's nothing left in that hierarchy below instance, so it's only going to impact that one door. If I were to make a type change, then I know that any change at the type level is going to impact all of the instances, and I can use that same logic as I work my way up. This is important to know because when we create our families, we're always going to start with one of these category templates. And so if I were to create a door family, I want to make sure that I start with the door template. The exercise that we're going to be doing is a casework family. And so I want to make sure I select the appropriate casework template. Within the casework template, we can see that we have two different options here on the top left. We have our family category and parameters, which is going to identify and define the category that we're working with. And then we have our family types, which is where we can go in and we can add multiple types, like we saw with the door family of the 36 by 84. We can adjust the parameters within the family, which will then be loaded into our project. And we can even do rename or removing types from this dialog box. Our first step will be picking the appropriate family template. I'll go to File, New, and Family. And from here, I'm going to look for the Casework wall-based Revit family template. This template already has a number of reference planes that we could use as the basis for the creation of our family. First thing we want to do is make sure that they're set up properly. I'm going to select the length parameter. I'm going to change the value from 4 feet to 6 feet. And what I should see is that all the reference planes move accordingly. I'll do the same thing with the depth parameter and make sure it works. It looks like everything's set up appropriately. To draw this casework family, I'm going to do it from the right side elevation. And you can see here we have another parameter, which is the height parameter. Just to make sure, I'm going to double check that one. It looks like when I change the parameters, everything works out the way it should. The first thing that we want to do is establish any of the other reference planes that we'll need to create this. And what I want to do is I want to create a couple reference planes that'll represent the toe kick. Using RP as the keyboard shortcut to create reference planes, I'll draw 2 more. And then I'm going to associate dimensions to each one of those. You'll also notice that I did not put in specific dimensions right away, because these are things that I can change after the fact. I'll set the depth of the toe kick to 3 inches and the height to 4 inches. Now I have a generic outline that I could use to create my base cabinet. To create the base cabinet, I'll use the Create tab, Extrusion, and I can use the Rectangle tool to create the generic mass for this cabinet. Using the Rectangle tool gives me the opportunity to lock all the constraints at each one of these locations, which will then allow me to associate the family geometry with the reference planes that we just created. After I've created the sketch and locked all the constraints, I'll go ahead and finish the edit mode. And at this point, I'll go into my 3D view, orbit around, and see what I've created. If we were to look at this in our reference level, you can see that our extrusion does not go the full length of the family. At this point, I'll use the Align tool so that I can line this face with the left extent of my casework family. I'll start by clicking on the left reference plane and the left side of the extrusion. When I use the Align tool, like we just did here, I get the option to lock the constraint. By locking that constraint, what I can do is now associate it with the reference planes that we looked at the beginning of this video. I'll hit Escape a few times to get out of that command, and then I'll check my parameters to make sure everything's working properly. As you can see, when I change the length parameter, the family geometry follows suit with the reference planes. I'm going to go back to my right side elevation, and I'm going to use a void to create the toe kick. I'll do the same exact thing, create, but instead of extrusion, I'll go to void forms, void extrusion, use the rectangle again, lock all the constraints, and finish the sketch. Now when I look at this in the reference level, I'll have the same issue, and I'll want to align and lock to the reference plane. And lock the constraint. Now when I look at it in 3D, I have a very basic base cabinet that we can use in our sample project. In this video, we're going to use symbolic lines to illustrate how the cabinet doors on this piece of casework open. We're also going to explore the options for showing those based upon the detail level of the view. And we're going to also look at how a room calculation point can be used for scheduling. The first thing I'm going to do is I'm going to draw a reference plane so that I can have a center point for the lines to terminate. And I want to make sure that's in the middle. So I'll draw an equal dimension so that I have a guideline to work with. Then I'll go to my Annotate tab, Symbolic Line. I want to make sure my subcategory is set to Elevation, Swing, Projection. And then using the reference planes as my guide, I'll go through and draw the symbolic lines. Now these symbolic lines may not be something that I want to show on every single view. So what I can do is I can select all of them using the tab option to select the chain of lines. And with visibility settings, I can control which view level that they'll show in. So detail level can control the visibility of family elements based upon these boxes being checked or unchecked. I'm going to go ahead and uncheck it for coarse, meaning that only when the detail level is set to medium or fine, those 4 lines will show up. So I'll hit OK. And you can see, because this view is set to coarse, that these lines are shown out as gray and no pattern. If I were to change the detail level from coarse to medium, you can see that they show up. For the room calculation point, I'm going to go back to our floor plan reference level. And in the properties palette, we have an option to turn on the room calculation point. And what I can do is I can select it, and I can set that point to show into a specific room. Using tab to select it, in this case, I can have it move forward to make sure that it shows in the room where the casework is being placed. In this video, we're going to edit an existing annotation family to add another parameter, which will include the floor finish for this room tag. As you can see, there's already room name, room number, volume, and area shown. We're going to add one more parameter at the bottom here that's also going to document the floor finish. First thing I'm going to do is I'm going to take the existing label here for volume, and I'm just going to copy it to be below it. The reason I'm doing that is I just don't want to have 3 things on top of each other right now, and it just makes it a lot easier for us to work. You can see that the volume parameter is already set to be associated with a visibility parameter, which in this case is to show volume. What I want to do is I want to associate it with a new parameter. So I'll click New Parameter, and this one I'm going to call Floor Finish. And we want to group this under Materials and Finishes. Now this label is not correct. Right now it's going to show the volume. I want to change that so that it'll actually show the floor finish. With it selected, I can pick Edit Label, and I have a number of parameters that I could choose. But in this case, I want to remove volume. So I'll select volume from the label parameters, remove it by selecting the red arrow, and then I'm going to look for floor finish, pick on the green arrow to add it to the label parameters and hit OK. The next thing I'm going to do is I'm going to go ahead and move it back so that it's lined up with the other ones. And this would give me the option to have a room tag that says room name, room number, and floor finish. Now, if I wanted to show room name, room number, area, and floor finish, then I would want to move this down to sit below, which is what we're going to do in this case. Now I need to check my family types to make sure that I have the correct checkboxes checked and a specific type for room, floor finish. So I'll click on the family types, and you can see here by default we have room tag, which is going to show the room name and the room number based on these checkboxes here. If I were to go to room tag with area, you can see that room number and area are showing. For the new type that we're going to create, I want to show room number, area, and floor finish. So I'll create a new type, and I will call this one room tag with area and floor finish. To make sure floor finish shows, I'm going to check the box and hit OK. Now we can load this into our project. And when I place a room, I could have it say room tag with area and floor finish. It's got the room name, the room number, and then it gives me the option to type in a floor finish. In this video, we're going to create a detail component that we can use as a standalone item, or we can use with the repeating detail component tool. For this assignment, we're going to use a brick as an example because that works really well with the repeating detail component. The first thing I'm going to do is draw a couple reference planes. That will be the framework for the different pieces that we're going to use. And then I'll just add some dimensions to make sure I'm drawing it to scale. The overall depth of this is going to be 3 5/8. And we're going to have a 3/8 inch grout joint. And a 3 5/8 brick. So these are the two areas that we need to fill in. And to do that, we'll use a filled region. I'm going to use the rectangle tool and just draw a rectangle in the first box, and I just want to lock all these constraints to make sure nothing's moving around. And make sure we have the appropriate filled region type. So change it to brick. And I'll finish that sketch. Now it doesn't look like much because our scale is set to 1/2 inch, but if I changed it to 1.5 inches, we start to see more of the pattern. Now I'll go ahead and do the exact same thing. This time I'm going to use the masking region. And this will represent our grout. And I'll go ahead and lock those as well. And finish the sketch. Now if I wanted to have a heavier line for where the brick is, I can edit that boundary. And I can revise it. Instead of using detail items, I could use heavy lines, and I'll get a more pronounced brick here. Now to make sure I have the draw order correctly, since I drew the brick first and the masking region second, I'm just going to go ahead and send the masking region to the back to make sure that the brick element is always on top of it. And that's how we create the detail component. Now I can load this into my project, and I could use it standalone, or I can add it to a detail that's already underway. And to do that, I can go in and I can use the repeating detail component tool. And all we need to do is make sure that we have it set appropriately. So here we have repeating detail brick, and that works out well for us. So we'll go ahead and use that option. And I just need to use the appropriate detail component and make sure I have the spacing set correctly. So ours was 4 inches, and hit OK. And now I just use a line to create that. And every time I hit that 4-inch mark, it's going to draw another one of the bricks. So I'll place it on top. And now I have the actual bricks shown instead of just a symbolic line. In this video, we're going to add some parameters to this bike rack family so that as we increase it in length, it'll add additional instances of the bike rack. For example, if I were to change the length on the parameter to any given number, you can see it'll increase the number of bike racks based on the length. The first thing that we're going to do here is we're going to add a reference plane to establish the endpoint. So our center reference plane here is going to be the start, and this will be the end. The next thing I'll do is I'll add a dimension, which will turn out to be our length parameter. I can add a label to that parameter by selecting it and then going in and adding the parameter. Since this template doesn't have any built in, we need to make one ourselves. So I'll select the Create Parameter button here, and I'll add a length parameter. Doesn't really matter what this is right now because we're definitely going to go ahead and change it later. The next thing I need to do is select the bike rack family that we started with, and I'll use my array tool. With array, what I can do is I have the option to use second or last. In this case, I want to use last because I want it to infill between the start and the end point. So I'll pick my first reference plane and just move it to the second. And I'm not too worried about this number because that's going to automatically be determined based on this length here. The next thing I want to do is make sure I use the Align and Lock tool to lock the second bike rack to this reference plane. So I'll use the Align, picking the reference plane first, and the point on the bike rack, and locking that. So now as I adjust this length parameter, the bike rack should move with it. The next thing we're going to do is we're going to add a parameter to the array number. To do that, all I need to do is select one of my array objects, and then I can pick the array dimension, and I can actually add a parameter to this as well. So I'll use add parameter. And I'll give it a name. I'm just going to call it the number of racks. Just keeping it simple. And then you'll want to group this in something that makes sense. So I'll use identity data, so that'll be easy to find, and hit OK. Now from here, I can go into my family types, and I can actually add a parameter for number of racks. And I'm going to use the length parameter as part of that equation. So a common mistake that a lot of people make is that they will just add an equation. So I want to have the number of racks be based on the length. And so let's say I want one every 2 feet. So I'll say length divided by 2 feet. So what this will do is it'll take the length and then it'll divide it by 2 feet. If this length is less than, say, 4 feet, then what'll happen is this number is only going to be 2. And the goal is to have one every 2 feet. And so this is a little bit longer than what we were expecting. So what I want to do is I want to actually adjust this. And I want to have this equation within parentheses. And I want to add +1 into here. So anything that goes below, say, 2 feet or 4 feet, see if I'm at 2 feet now, and I hit OK, it'll give me 2 bike racks. But if you see, if I were to not have it set up that way, then I'm going to get an invalid warning, which is telling me that now, because I've got it set to length divided by 2, it equals 1, and it doesn't like that. So we want to make sure that we always have our parameters set up to be an equation and then giving us +1 when we're using it for this type of application. Now what's cool is I can go in and I can change the length to any number, and it'll extend the number of instances based on the length using that formula.